fields of electrical engineering. We might call them of electrical engineering, electrical and electronic engineering, telecommunication engineering. All are the same. The most important thing is they are subfields, and I will discuss them in brief without really taking too much time. So the first one is that one of solid state electronics. Solid state electronics, as we have said, started with the invention of a transistor. In the old days, the biggest challenge was to how do you amplify a signal or amplify power. Of course, you know the concept of amplify. You have a lower voltage signal, you pass it through a device. This is an image of a transistor, and I don't want you to necessarily know about it. But if you have a low signal here, it's normally called base, emitter, and collector. Don't worry about the details. And then you have some higher voltage, VCC, at this point. You are supplying some higher voltage here, some low current is being supplied here. This resistance will receive this signal, but at higher voltage. We'll receive an amplified input signal. Don't get worried about the mathematics here involved here, but this is the symbol of a transistor. The signal that is getting at the input will be amplified by the transistor that is getting powered by the VCC, such that this will also receive the signal that is coming in here, but now it will be received amplified by the voltage that has been at the transistor. So what I'm simply saying is that in the very early stages of engineering, the biggest problem was how do you amplify a signal. So this gadget called transistor was invented, and therefore it allowed that aspect to be achieved. But the old days of amplifying required consumed so much heat and so much power that there was a requirement that we have a more compact device that would allow us to achieve the amplification of a signal despite the earlier challenges that were there. So what we are simply saying is that the invention of a transistor actually gave birth to what is now called solid state electronics, because the idea of an IC, because you might have heard me talk about an IC before, the IC is integrated circuit, and we are saying that once the transistors were invented, they can be miniaturized. And miniaturized simply means they can be made very small and put in one circuit called IC. So you might have a transistor that is embedded in this chip, and probably many of them, and they are able to achieve very high level of amplification that was not possible before the advent of a transistor. And when we have many circuits miniaturized to be in one IC, that is what constitutes solid state electronics. Simply says that we have many ICs in one small circuit, and they form an IC, and that IC can perform one function. That kind of miniaturization is the one that allows us, or that field that allows us to do that kind of miniaturization is the one that we call solid state electronics. And therefore what we are simply saying is that this is an image of a vacuum tube that was a predecessor of transistors. So you can see this very clearly is there's some vacuum that is involved that was used. We used to have a vacuum that was performing the work of amplification. It was not possible to miniaturize or to make them very small. So there was the minimum that you could achieve. So, but at the advent of the transistor, we were able to perform the function that this big gadget was performing, that is of amplification, by using a very small gadget that is called a transistor that could be filled in a small IC and still does the same function. So what I'm simply saying is that this field called solid state electronics came as a result of the development of a transistor. And therefore you can of course notice that it is from the miniaturization of transistors and others, diodes and other small circuits, that now led to the concept of a microprocessor. And he's saying that it was first introduced by Intel in a form that is called 4004. And these are the story. But the most important thing is that we have a single chip CPU. CPU is a central processing unit, that more of a computer that is running on a chip. So that is where we are now. With the solid state electronics, we are able to have a computer, and a computer is a device that can perform many tasks depending on the user instructions, and that was possible because of the idea of transistor that can be put in an IC, and IC can become very small, and we end up with a single chip microprocessor, and that is actually has led to where we are today in the terms of computer engineering. We are able to have very small computers, the small phones, the small laptops, very smart devices that we have today became as a result of the growth of solid state electronics. Of course, that was a precursor of the many fields that we now have, the many others that have blossomed, and we will start with in the power systems. We have, and I think we have said that in the past, we have power generation, power transmission, and distribution. That is a whole field of one field of electrical engineering. We'll also find power electronics. I think I have also mentioned this, that high voltage engineering is also a subfield. There is another one called power. So I was saying there is a high voltage engineering, there is power electronics, and I don't know necessarily to discuss power electronics now, but power electronics is concerned with electronics that are used at high voltage. Power electronics is the application of solid state electronics to the control and conversion of electric power. And there are very many power electronics devices that are used in high voltage today. The key idea is that for us to transition from high voltage to low voltage, we normally require devices that allow us to do that conversion. And some of those are resistors, power transistors, among others. So in general, you will find that power electronics deals with those devices that are concerned with conversion of power, control and conversion of power from mostly from high to low and low to high. So that is purely what power electronics is involved with. Therefore, we are not necessarily going to dwell so much power. As long as you understand the basic meaning of this, that is all that for you for at this stage is required. And of course, a term that I have always encouraged my students to know is that of power grid. Power grid is a network of generators and transformers that allow the power to be transmitted from the source or from the generation, say from Masiga, from Kidaruma, from other sources of electric power to where the power is used. So that grid where we are getting power from the source, from Kidaruma or Masiga, to the point where it's being used in your house, that interconnection of many electrical components, that is the one that is referred to as a power grid. So another field of engineering is the one that is called control engineering, and I think I have mentioned about control engineering in the past. The simplest example that I gave you is the one that deals with controlling and then an engine of a car, such that you don't have to have a manual changing of gears, but the engine itself is able to detect when it should move from a higher gear to a lower gear and vice versa. That is the simplest example. And now there are so many others, other systems that deals with control engineering. And we are saying that simply control engineering focuses on modeling of diverse range of dynamic systems and the design of controllers that will cause this system to behave in a desired manner. And I think I've also given you the example of a lift. I'm just trying to give you the simplest of examples that you can get. A lift, you are in a certain floor, you want to move from this floor to a higher or lower floor. When this lift starts moving, really it doesn't jump like at the same speed of moving from the second floor to 10th floor. When it starts moving, it starts accelerating slowly, picks up high speed, then when it is stopping, it is stops again with a deceleration. So those things, particularly acceleration and deceleration, are controlled by a controller. The idea is that there is a controller that is concerned with managing this dynamic system. Purely, whenever you're in a lift, whenever you are in a car and the car is changing gears, just know that there are some controllers that are running, controlling the change of speed, change of power, change of very many aspects of that device, so that it achieves a desired behavior. And that is what we have said, that is what control engineering is concerned about. And the last example I have given you, and I think I expect you to know, is that of our door. some of you might have seen their doors. I'm drawing a simple door. There is a system that is normally placed here at the door that when you release this door, it doesn't bang. It pulls the door towards closing, but as it draws closer to being closed, the speed and acceleration reduces and it closes very slowly. That kind of a system, another very simple controller that you can see in your daily life that allows you to view what control engineering is about. And that is some of the things that electrical engineers are concerned with. We have talked about electronics in very many forms. Electronics are the small gadgets that allow you to control power or control signals, and they constitute devices like capacitors, inductors, diodes, transistors. And what this simply do is that power electronics, this is normally used for at high level or high voltage, but now at the electronics level, we are normally concerned with very low voltages, and therefore we normally use these devices. And therefore, whenever you talk about electronics, you're talking about the small gadgets. It might be small, but not necessarily very small. But when you talk about resistors, capacitors, transistors, and among others, and them from doing one function in a combined form, then they are considered to be part of an electronics gadget. Of course, electronics can be split into microelectronics and nanoelectronics. Again, a field that is a bit specialized, which we can always read more on ourselves. Nano is more concerned with a very small size of devices at a nanometer level. Micro is concerned at a micro level, like micrometer level. The most important thing we are talking about is the size of the gadgets, of the components that are involved in the manufacture of those gadgets. So the smaller they are, the smaller the name changes. So we might have nanoelectronics. You are reducing the devices to become very small. All of these ideas came from where we talked about solid state electronics. It is the solid state electronics that allowed us to start moving to a very small sizes of gadgets. Signal processing, which we have again said in the past, like right now I'm talking. So my signal is being captured. So there is a source, me. I'm using a mic. So a mic receives my signal and converts it to electrical form, electrical signals. And then this electrical form is then taken to a processor. This signal processor will convert this signal to probably a digital format. So we have ones and zeros. So that this can then be transmitted to you via many other formats, be it wireless, be it wired, etc. The device that is concerned with filtering noise. So talk about from identifying echo, filtering noise, amplifying the signal, and all those constitutes to what is called signal processing. So that signal is in a format, is converted to be in a format that is usable, that can be of use to the recipient. So all those functions that are concerned with transforming a signal from amplifying, transmitting, reducing noise, moving echoes, and even converting to a digital format, all those processes are the ones that are defined as signal processing. It can be either analog or digital, and the details you can of course read through about what that involves. But I've just introduced you to the concept of signal processing. And I think we have also talked about the communications. This is purely anything that allows you to transmit signals from one end. The communication aspect of electrical engineering is the one that is called telecommunication. So you might be concerned with how airplanes communicate with the ground, so that you can know how to land or this. Talk about satellites, how they are able to receive signals from the ground up and back and forth. Talk about mobile communication. All those concepts revolve around telecommunication, and that is a whole field of electrical engineering. So you don't necessarily need to dwell there. Even fiber is part of telecommunication engineering. So in telecommunication, we are mostly concerned with transmitting and receiving signals and how well they use power.